Hey there, this is Jenny Chen. I'm the founder of 3D Heals. Welcome to the Lattice podcast, the official podcast for 3D Heals. This is where you will find fun but in-depth conversations with technological game changers, creative minds, entrepreneurs, rule breakers, and more, focusing on how we can use 3D technologies like 3D printing and bioprinting to reinvent healthcare and even life sciences. This podcast will also include AMA or Ask Me Anything sessions, past Instagram live interviews with influencers, and other direct engagements with our tribe. Thank you guys for joining us. Feel free to type your questions for Daniel today as we are talking, and I'm happy to address these questions or concerns at the end of this interview. So I want to introduce Daniel Martínez Pereira. I hope I pronounced your name correctly.
It's okay. Don't worry.
What should I say? Pereira?
Daniel Martínez Pereira.
Okay. I have to practice.
It's the same. Don't worry, Jenny.
Okay, great. Awesome. So Dan is a co-founder of an awesome antimicrobial 3D printable material company called Copper 3D. I like the title of your company because it's very clear to tell everybody what it does. And so Dan, you actually have a very long track record in doing innovations in healthcare, and currently you're the Chief Innovation Officer for Copper 3D.
Yeah.
And you've been all over the world when pandemic hasn't happened, and you're visiting US and you're visiting the world to find partners and collaborators for Copper 3D, which is still at a small startup. So at a very early stage.
Yeah.
So after that intro, I think everybody kind of want to know, what is the story behind starting a company? Because you're definitely a veteran in healthcare. Why did you decide to do this?
Yeah, it's a long story, to be honest. This is my third company, my third startup. I'm the entrepreneur of the team. We are a senior team of professional. We are not young guys. We are in our 40s. But the story of Copper 3D starts in an academic context, in a Master of Innovation here in Chile, where I met my colleagues, my partners, Andres and Claudio. Andres is an electrical engineer, and Claudio is a medical doctor. I'm a physical therapist. This is my profession. Then I get an MBA degree, and then a Master of Innovation. So my background is in the marketing, in the management sector in healthcare industry here in Chile. Basically clinics, hospitals, and pharmaceuticals. Okay. And in the context of this master, we are doing the job that innovation does, basically to found for big global problems to solve. And we get to this very interesting mix between 3D printing and medicine. And we started to look into this intersection of these fields. And we get to this problem of the high bacterial burden, the high bacterial load that has this, for example, this kind of orthosis or prosthetics in 3D printed, okay? So it's a big problem. I mean, 3D printing is an incredible technology, but when you land this technology into healthcare, you're starting to look at this problem of bacterial burden. And bacterial burden in a medical device is a huge problem, because if it's this, for example, you will expect to have skin irritations first, and then fungal or bacterial infections in the skin. So it is a big problem. So that is the first observation that lead us to the work of Copper 3D now. So basically we says maybe we can solve this problem. And this is not a problem of the design of the medical device. This is a problem of the material. This material is a polymer. This is PLA, but any material is a polymeric material. It's porous, complex geometries. This is not easy to clean, for example, for a patient. So you will expect high bacterial burden. And then we realized that we need to hack the materials used by the 3D printing industry, and most of all to use it in the biomedical 3D printing industry. And that was the initials of Copper 3D. Basically, what we do is we hack the materials with an additive based on nano copper. It's a patented additive. It's a Chilean development. We are, we are Chileans. We are expert in wine and copper. That is our expertise. Yeah, it's true. We have pretty good wines here in our country. So yes. So and then innovation drives you to prototype, to test, to validate, to make validations of the market, the business model, and all the journey of the innovation process. And then we decided when we closed the program, the academic program, we decided to move forward and to go to market with the first material, which is this one, which is PLA active. Mm-hmm. And with this material, you can think about the first the initials of the antimicrobial 3D printing sector, which is now a sector. We have competitors. It's a booming sector right now.
That's right. Yeah.
Yep. And we are still in the middle of a pandemic, so we have right now a huge awareness of the global population about the virus, bacteria, fungus, and infections, and this is a huge problem right now. So we are in a good spot today. We are trying to help. We are trying to collaborate with our community and to other communities around the world to inspire the professional sector and the pro maker sector to develop new antimicrobial objects, antimicrobial things for the use in like everyday objects, but also like medical devices. Why not?
Awesome. Yeah. No, I remember you guys came out before the pandemic. When pandemic and antimicrobial is not really everybody's focus in life. But it's really the pandemic sort of kind of put you guys in a spot in a way. And you already answered the question that I wanted to ask is why did you pick copper? Because there's other metal materials that can use, like silver and zinc that you could do similar things, right?
But the answer for that is a very good question. We choose copper because again we are expert. We are a country expert in copper. But besides that, copper is a very human-friendly material, if you want. It's not cytotoxic. At least our additive is not cytotoxic. It's biocompatible. So you didn't expect to have problems in contact with the skin of the patient, for example. And the other aspect is the price. I mean, nano silver, nano gold are also working additive, but the price is like double or triple or even more. And the price of nano copper is less and is super effective. It's even more effective than nano silver. So that's why we choose copper.
Cool. I love to talk more about economic side later on, but right now let's focus on the technology side. So pardon me of my ignorance, and also do not devour any kind of preparatory information in public. Is this something like you have to modify the copper first before you add into the PLA filament, or is it just like powder you just add it in there? Yeah.
Again, very good question. If you see PLA active, for example, you see basically PLA. This is regular PLA, okay? You don't see like the heaviness or the color of copper or of actual copper, of the metal copper, okay? So the first thing to clarify here is this is still PLA and behaves as PLA, but what we do with the additive is first, this is a super fine powder of nano copper in a salt of copper formulation with other elements that call carriers and stabilizers of the additive. With that elements, you can avoid the particles to make clots, because clots can ruin the material. You lost the homogeneity of the material with this clot, with this agglomeration.
Mm-hmm.
So this is a very important aspect. And the other aspect, which is super important, is these other elements that acts as regulators of the rate of liberation of copper ions. Because everybody ask us, what exactly eliminates a virus or a bacteria? Is a nanoparticle? No. The answer is no. You don't see nanoparticles going outside the material. The nanoparticles are embedded, are trapped into this polymeric matrix. But what the additive does is that releases copper ions. We are talking about subatomic particles, okay?
Yeah.
Copper ions. And these copper ions is like a subatomic bullet that break the membrane of the virus and the bacteria, and once inside, break the DNA or destroy the DNA. And this is a very, very, and in fact, you have 4 different mechanism of actions of these copper ions that acts in parallel and very quickly. So that is a very important thing, because, antimicrobial resistance. Antimicrobial resistance is bacteria that learns the mechanism of action of an antibiotic. But in this case, when you have nanocopper and you have these copper ions, there is 4 mechanism of actions acting in parallel. So there is no way that a bacteria, for example, can learn and bypass and get resistant to these copper ions or these nanocopper additives. So that is a very important aspect today, because of besides COVID and all this pandemic situation, antimicrobial resistance is a huge problem right now inside the hospitals and clinics and healthcare facilities.
It's the one of the top morbidity or effect of going to a hospital. I mean, hospital is really not that safe if you think about it.
Yeah.
So let me just summarize what you just said. My understanding is you're saying basically the nanocomposite, and the reason why it's called composite, you have all these other chemicals that holding the copper iron stable, so that you can embed this into, say some other materials, so that it can be used and released in a proper fashion.
Exactly.
Okay, cool.
Exactly.
And so I have quite a few questions on the tech side also. Is this going to create a super bug? Because think about it, if you're like killing these viruses and bacteria, and we're all now kind of worried about mutations and variants, is this going to create a super bug?
I don't. Well, literature. This is not what I think. Literature says that there is no way that a bug, for example, a super bug, can get resistant to copper because the different mechanism of actions that act from copper through a bacteria or a virus. But eventually, maybe in the future, you can get a strain of bacteria, for example, that maybe can get more resistant to copper. And when that could happen, we are already developing more additives, because this is pure nano copper, but you can mix nano copper plus nano zinc, or nano zinc plus nano silver, and you can put into these materials different formulations of additives.
So we're outsmarting the bacteria in a way.
Yep. Yeah. Basically, that is how we think, is how we can, through nanotechnology and polymers in this case, or materials, how we can protect us from these very dangerous microbes.
Awesome. And then you said you hacked material. So the first kind of material you hacked for 3D printing is the PLA filament, which I really like it, because it's a sustainable kind of material from from the 3D printing industry. But what about the other materials? Are you guys thinking about, creating some products as resin based?
Absolutely, yeah, absolutely. Well, the second material is MDFlex, which is a TPU-based material.
Okay.
This is, for example, a cell phone case 3D printed with MDFlex.
Yeah.
You can see it's flexible. But obviously, we are moving to other technologies with basically SLA, SLS. You have a huge potential there. and you can disrupt the you can really disrupt the medical device industry with imagine this with medical device like that perform also as a wide spectrum antibiotic. It's a medical device plus antibiotic. That is a super disruptive thing, and we are moving in that direction.
Cool. I know that you brought some examples and you already showed us a couple. Do you have something more you want to show us? That's the fun thing
Yeah,
about Instagram
I have a lot of things. I want to show you first. I want to go from complex to more simpler objects.
Okay.
This is a cone. This is the half of a cone.
Okay.
I don't know if you can see.
Yeah. Mm-hmm.
Okay. What is this? This is a prototype of an interface between mother and child. And this is to prevent the transmission of HIV from mother to child through breast milk.
Oh.
Yeah. Again, this is a prototype, but we test the concept in laboratory. We test the concept in a microbiology laboratory here in Chile. And the thing is, let me get my if you put contaminated milk in this case,
yeah, mm-hmm.
contaminated milk, and you pass the milk for this like maze structure.
Yeah.
You get to a situation where you can expand the surface of contact of the milk with the material. This is an active material. And with this expansion of the surface of contact, you can expect to a very steep decrease in the viral burden in a couple of seconds. This is validated in laboratory. We want to move forward and to test, to make like field tests, and we are also working with a university here in Chile to test this with another university and a couple of hospitals in Africa. That is like a social project, if you want, for us. But we really want to validate this, because if you can, the other thing, this is a cone that you can put inside like a milk extractor or like a bottle for babies,
yeah.
A pump, okay. But basically the thing here is this is actually working, okay. So the concept, and you can apply this concept to other objects. For example, let's think about the bottle where you pour contaminated water and you pass the water for a similar structure than this, and in a couple of minutes you can drink that water.
I think that's awesome. Yeah, it can be applied to many different things, even just a
filters.
Regular drinking water for me to carry around.
Yeah, absolutely.
Why
or for hikers.
Yeah,
the hikers in the woods. It will be also a very cool application. So this is one of the concepts that we have already validated, and we are thinking about what we can make with this concept, and with in collaboration with who, and to address what specific problem. We are in that process right now.
That's awesome.
That is like a more complex application, but into the more simpler applications. Well, you already see that this is a injection molding mask. This is the Maverick mask. So this is a material called laprine, which is basically the same material that you can find in the scuba dive mask, but this is an antimicrobial laprine. We put additive to everything. So this is an antimicrobial mask. Another application, and this is very interesting. We are about to launch today a couple of designs for iPhone. I think it's iPhone 11 and iPhone 12 for basically a cell phone case. And the problem with the cell phone case, and it's very well validated and very well studied. You can expect to have around 20 or 30 times the bacterial burden in this object more than in a public restroom. So,
Oh
so
my
this
God.
is this is 30 times more contaminated than a public restroom. That is the studies. That is science.
That's
Yeah,
really gross.
yeah, it's gross, but maybe it's not a huge problem for me or for you. But if you are a doctor, or if you are a nurse and you are in a hospital, and you are with patient, this is a problem. So in this situation, in this COVID situation, we wanted to first to make a statement as a company, as first the awareness of, hey, you have in your pocket like a super filthy element. You can wash your hands 100 times a day, but you touch your cell phone more than 200 times a day. So it's impossible to have your hands clean touching your cell phone. So an antimicrobial cell phone case is a super simple application, super simple application, but it's super effective in stopping or breaking the chain of contamination from hand to object to hand. And we are about to again to liberate this design, and I hope to the community to download the design and to start printing with antimicrobial materials. That is the idea, and goes very well. It's a very simple, sleek design. We have different designs for cell phone case. So and the other thing we you can think about, but what about scale? How you scale because this is a 2-hour print, okay? But we are already producing and this is injection molding. This is like a more professional, if you want, or more industrial cell phone case. This
Yeah.
is made in China with our polymers, but
Okay.
this is injection molding. So this is an antimicrobial injected molding cell phone case, and
So
we are about
just answer my question that's in my head is your material can be applied to many different manufacturers.
the additive you can use the additive into the 3D printing sector in any technology, in FDM, SLA, SLS, and so on. But you can put the additive into, or you can use the additive in other technologies like thermoforming or injection molding. And this is injection molding. Okay, this is a more industrial way to produce an object. So you can in that case, we are not talking about filament. Obviously, we are talking about pellet in a pellet format. In a additive, you can mix the additive with these polymers, and then you inject the polymer, and these babies goes to laboratory and prove that it's also antimicrobial. And that is because the additive is not because obviously the polymer. So that is the magic behind what we do. We can hack any material. You can use that material in different technologies, 3D printing or outside 3D printing, and you can create antimicrobial objects.
So,
Very cool, isn't it?
so Copper 3D really is beyond 3D printing.
Yeah.
It's basically auto manufacturing process.
Yeah.
Now going back to the story that we started this conversation is how you started the journey. You guys were trying to solve intersection of medical device and possibly using 3D printing.
Yeah.
With a better material. This concept of this material can be applied to all manufacturing. Is this like something that came later, or you guys always had this idea at the beginning?
No. We had this idea at the beginning because, again, we are a country very expert in this kind of antimicrobial additives. Just for you to know, in Chile we have Chile is a hub of innovation around antimicrobial solution cover based. Okay, there is a lot of companies here doing, for example, antimicrobial textiles, like for scrubs, antimicrobial scrubs for medical staff, antimicrobial toothbrushes, antimicrobial towels, underwear, paints, coatings. There is a lot of companies doing a lot of things. And we take this additive and put into the 3D printing sector, aiming to solve this problem with medical devices. But again, you can take this additive and put into another into another polymers for another applications in another industries. So in the future, in the near future, for example, you can expect to go to an airport. You see the trays of the airport are super filthy. You can think about antimicrobial trays in the airport or inside the airplanes, antimicrobial takes or polymers in the seats of the or in the cabin of an airplane. So there is a lot of applications of the additive, and obviously a lot of applications into the 3D printing sector.
Cool. Well, in a way, it sounds like I shouldn't be surprised that Copper 3D happened in Chile.
Yeah.
So I'm going to end with let's see if, okay, there were some questions. I'm seeing some questions.
Okay.
Well, I have one final question for you before I go to the questions. What are some of the big lessons starting in your startup journey so far that you've learned that you can share with us? So many.
There is many lessons, but if I can give you like one lesson, like for me, what is the big one lesson is this: to found a startup it's a tricky thing. It's not easy. It's difficult, and you have to you need a super strong fuel, and that fuel is passion about what you're doing. If you don't have passion, and if you really don't believe that the project where you are is not impacting the world, you have to switch and think about anything else. But if you really believe in your technology, if you really want to make an impact, and if you really want to go beyond your frontiers, I mean, again, we are in Chile. We are in the south of the world, pretty far away from the big centers of innovations. But if you are not really passionate about your project, maybe it's not your project.
That's a really good advice. I echo the same. All right, so we have one question for you. It says, where can we buy the phone case? By PayPal.
Right now we are not selling the phone case yet. We will, maybe eventually we will, but you can download the design of the STLs of the iPhone 11 and 12 from cover3d.com in applications. In applications, you put MD case.
Yeah, but they can buy your filament anytime they want.
Yeah,
right?
Yeah, absolutely. We have a huge network of resellers around the world. Yeah.
Can they buy it online directly, or they have to buy it through some reseller?
Amazon. In US,
Amazon.
You can go to Amazon. Our distributor there is 3D Print Life.
Awesome. I will share those links after the session.
Perfect.
And it doesn't look like we have more questions. We're also kind of running out of time, unfortunately. But Daniel, it's always a pleasure to connect with you, and I'm sure we can do another Instagram Live some other time and have some updates for everybody. But thank you so much for the session today. And
thank you for your invitation, Jenny. Great talk to you.
Okay, awesome. Bye-bye.
Take care. Bye-bye.
That's it for this episode. Be sure to follow us on Facebook, Twitter, and Instagram at 3D Heals, and check out the links in the show notes. See you next time.